The universe is an incredibly strange place that presents any number of mysteries and strange attributes that present a complexity so great we've spent centuries trying to figure it all out. And while we have lots of bits and pieces that are experimentally valid, we do not yet have a complete picture of the universe. There remains many mysteries about it, such as how did it begin? Why did it begin? Why does it behave as it does? Why does time only tick forward, and so on? So far, a complete theory that explains all of these observed attributes has eluded us, especially in the case of the nature of gravity. But one thing is clear. The universe seems to have started very simply, explained only by 4 factors really, and then has become extraordinarily complex as it is right now as we observe it, but will someday return to a state of simplicity after all the stars and galaxies have blinked out. Even today, the larger the scale in which one looks at the universe, the simpler it seems to become. In fact, it's long been noted that the universe on its largest scales actually in some ways resembles a particle. Now granted, it's also been said that in some ways it also resembles the interior of a black hole and maybe even a white hole. But a black hole itself, in some ways, resembles a particle as well. It's almost as though the large scales of the universe can mimic the smallest scales in some respects. While strange, it may suggest an underlying simplicity to the whole thing that somehow gets lost in the complexity of the universe as we see it at our level and our time. But questions regarding the nature of the universe have led cosmologists in 2 different directions, trying to rectify the whole thing with ideas such as the multiverse, or the many worlds interpretation of quantum mechanics, where the universe is constantly splitting into alternate timelines. But it may actually be much simpler than that, and there is now a hypothesis out there that may explain some of the greatest mysteries of the cosmos quite well, without delving into the concept of multiverses and alternative timelines. But it does imply something strange in itself, an anti-universe. The idea of that bases itself on the concept of symmetries in nature. There seems to be a duality in quantum mechanics, setting aside many other dualities in nature on our scale. The dualities of nature are rather odd in and of themselves. There are 3 symmetries in nature that are very apparent in subatomic particles. One is parity. In other words, if you hold a mirror up to an interaction, the result is the same in the mirror, so to speak. Another is charge. If you have a bunch of particles of one charge, if you flip things to the opposite, you get the same interaction. The last is perhaps the strangest. It's time. If you run an interaction forward in time, and then look at it running backwards in time, the result is the same. This is not unlike dropping an egg on the kitchen floor. The egg falls and shatters, and its innards go everywhere. But you can imagine running it backwards, and the same set of events happen in reverse until the egg is whole again. That's basically how nature works. But it's never been clear in physics why it only goes one way in time. There seems to be an arrow of time, as it's termed, that only points in one direction. But why never the opposite direction? There's no clear reason why, leading to hypotheses such as those of John Wheeler decades ago that maybe particles can run backwards in time, and we from our perspective see 2 particles, whereas there is actually only one running backwards and forwards through time as we see it, as it passes our frame of reference as 2 particles in a kind of illusion. In Wheeler's case, this was the idea that there is only one electron in the entire universe, and all the electrons we see are actually the same one bouncing back and forth through time over and over. This idea has since been somewhat relegated to obscurity due to a lack of supporting evidence, but the general idea of particles being able to move backwards in time hasn't. So if they can do that, where are they? Cue in the idea of the anti-universe. Given that the universe seems to like symmetries inherently, it becomes puzzling when one sees asymmetries in nature. One major one of note here is the apparent asymmetry between matter and antimatter. The current best hypothesis for this is that something about the earliest moments in the Big Bang caused a slightly higher amount of normal matter to be generated as opposed to antimatter, despite matter and antimatter always being created in pairs, in a sort of heads or tails situation. Matter and antimatter should have been created 50-50, but some unknown factor intervened, and tipped the balance towards normal matter. As a result, most of the matter and all of the antimatter in the early universe annihilated, leaving only a small amount of normal matter left in the universe, which is the normal matter we see today, and indeed are made up of, along with tiny amounts of antimatter created by various processes. But that's not the only idea that's been advanced. There's also the idea of an anti-universe. One possibility with it is where the antimatter is still around. This is where all the antimatter generated by the Big Bang exists, in an anti-universe mirroring our own. This leads to ideas that maybe antimatter in that universe experiences time backwards, and even some kind of antimatter version of us existing there, running in reverse, though maybe not identical. It doesn't have to be. That leads us to the second type of anti-universe, or another aspect of the first, which has a striking simplicity to it, and its ability to oddly explain all sorts of mysteries observed in the universe is noteworthy. Once again, we return to the three symmetries of physical interactions. While you do see symmetries get violated like matter and antimatter, you sometimes see them in instances involving individual symmetries, but you never see a violation of all three of the symmetries at the same time. If you flip all three symmetries, the interactions are the same. This is usually termed CPT symmetry, short for all three involved. But what if you scale this up to the entire universe, as though itself truly does act like a particle with symmetry? You get an anti-universe counterpart, at least of sorts. In a paper by Latham Boyle, Kieran Finn, and Neil Turok, link in the description below, they detail that if you apply CPT symmetry to the universe itself, you notice that our picture of it isn't complete, opening the way up for something more. What fits nicely there is an anti-universe. The anti-universe idea in this case basically is a mirror image where all of the charges are flipped, like matter and antimatter, but again, they run backwards in time. The arrow of time is flipped opposite as part and parcel with the antithesis of our universe, which preserves the symmetry. This both explains some things, but also creates a problem. The problem is cosmic inflation. There is mounting evidence for this event, where the universe during the early stages of the Big Bang inflated for a time at a much faster rate than it does now. Within the CPT universe idea, you don't need inflation to explain the rapid expansion, and it's not completely clear if that fits with observations, which seem to support inflation. On the other hand, the concept of inflation is in itself still a bit shaky, so there may end up being no need to invoke it as more is learned about the early universe. It's up in the air, and probably will be for a long while. But then you get to the important implication of this idea. It may explain the existence of dark matter. This kind of symmetrical dual universe would mean that there are more neutrinos in the universe than we may have realized. Neutrinos are interesting here for two reasons. The first is that they sort of behave like the most popular view of the potential nature of dark matter. This idea is the WIMP, or weakly interacting massive particle. In a nutshell, the WIMP idea for dark matter is that the culprit for its existence is an unknown particle that interacts with gravity, and the resulting gravity can be observed in galaxies, but it interacts with nothing else. This sounds a lot like a neutrino, where they don't really like to interact with normal particles. Only occasionally does it happen through the very short-range weak force and the absurdly weak force of gravity, which on small scales is almost non-existent. And while we can detect the odd neutrino when it passes close enough to interact with something, most of them pass through the Earth like it was nothing. While it might seem strange that particles can pass through entire planets, it pays to remember that most of an atom is empty space. In fact, the vast majority of it. So if you have a particle passing through that doesn't interact with the other particles that make up the atom, then it can pass through the empty space without issues. And with gravity on the subatomic scale being so incredibly weak, it doesn't play a part at that scale. So unless the neutrino basically hits something head-on for the weak force interaction to kick in, it just passes through atoms like they're nothing. And that brings us to an odd mystery about neutrinos. They are very similar to electrons, but without charge. There are three types of neutrinos, tau, muon, and electron neutrinos, but it's possible that they are all the same thing just in different states. Yet particles in physics typically have two types, known as chirality, usually referred to as left and right-handed. Yet the neutrinos don't have this. They're all left-handed. In the same grain, antineutrinos are all right-handed, and there's no particularly good reason for this. In the new paper, however, it's predicted that at least one type of right-handed neutrino should exist. It would only ever couple with gravity and have no other interaction. Welcome to the land of dark matter, oddly enough. And it just so happens that the predicted amount of right-handed neutrinos fits quite well with the predicted amount of dark matter in the universe needed to explain the anomalies we see with the behavior of galaxies and the gravity involved, perhaps solving one of the greatest mysteries of the universe at this time. And one of the perhaps strangest implications of all of this is that our anti-time CPT universe would actually provide a way for a universe to exist before the Big Bang, but not in the same sense as being a precursor, but sort of telescoping behind it backwards in time from the Big Bang as a twin. Think about that for a moment. Perhaps one of the most interesting aspects of this paper is that the idea may be testable, specifically in trying to look into predictions on the masses of neutrinos, including a massless one. One oddity here is that one of the predicted masses of a right-handed neutrino matches observations done in Antarctica via balloon that detected anomalous particles traveling through Earth with a mass very close to that which is predicted in the paper for a right-handed neutrino, and it may have been the decay of such a particle. But while the mass fits what is proposed, the fact that it decayed doesn't, as the neutrinos should be stable in the CPT universe, so it's uncertain what actually happened with that detection. But the universe itself may provide its own answer, in the form of gravitational wave evidence of inflation. If it's found that inflation happened, then this anti-universe is dead on arrival. And that's probably the Achilles heel for this one, in that there is some mounting evidence that inflation did indeed occur, as odd of a proposition as it might seem. But if no conclusive evidence is ever found regarding inflation and gravitational waves, it may point to this one being right. We shall see, but it's an interesting idea in its elegance, symmetry, and its potential explanation for such vexing things as dark matter. Perhaps it will turn out that dark matter wasn't as complicated as it might have once seemed, and may have even been detected in Antarctica. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently invoking an anti-universe. It's a strange place called Event Horizon where an anti-me conducts interviews while getting pestered by a quantum mechanical possum and a folk-singing artificial intelligence. About a year ago, I spoke to Dr. Turok about these ideas more in depth, link to the interview below, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.